Hello, welcome to another episode of Tiger's Maths. Right, I'm going to do the Pixi predicted paper. Which one's this one? This is 2B. So here we go. Let's see how quickly we can do this one. Right, so question 1. This is a calculator paper, so I need my calculator handy, don't I? Right, so I've got 3 significant figures, so I'm doing is 1, 2, 3, counting in. I'm looking at the fourth one, it's a 7. That means I'm going to round to the nearest 10 here. So it's just going to be 7,360. So 7,360. This is clearly just a calculator job. So grab your calculator out, put it in as it looks. So pressing the fraction button, turn the calculator on, fraction button. Square root of 17 plus 4 squared over 7.3 squared. Now this bit should look exactly like the question before you press go. The problem here, you might press the square root button first, which means you'll have the square root button all over everything instead of just being on the top of the fraction. So press go now. Oh, that's a cube actually. Delete. Change that to a cube. I haven't got my glasses on so I can't see. There we go. Ends up as this number here. Is that alright? Yep. So 0. What does this say? Write down them all. So 0.014768 6789. That's them all. I might as well write them all down. I think they give you it if you write maybe 5 or 6 of them down, but it says them all, so just why not? Robert's worked out, has been asked to divide 120 in this ratio, 3 to 5. He's just working out. He's did 120 divided by 3 is 40, 125 by 5 is 24. His working out is wrong. What he did, he's forgotten to add the 3 and 5 before they're doing division. So Rob should add 3 plus 5 before dividing. Okay, now it should be, so 3 plus 5 equals 8, and then 120 divided by 8, grab your calculator, 120 divided by 8, every calculation should be done on your calculator, and then you've got 3 times 5, 15, sorry, and then you've got 5 times 15, which is equal to 45 to 75. Okay, that's what the real answer should have been. If the camera's a bit blurry, it's because I have my glasses on. Should have put my glasses on, shouldn't I? Next one, Peter's asked to subtract this from this one. Here's his working out, so this is a good line. So he's wrote his first thing, then he's wrote the subtraction, but then he has been careful with his negatives. So he's been mistakes with negatives. That's what he's done wrong. So it should be x squared plus 3x plus 5. Take away, and then you've got x squared, take 2x, take 4. This is equal to x squared plus 3x plus 5. Take away x squared, but then this take away hits this negative, so we get plus 2x, and then the negative hits that negative, and you get plus 4 at the end. And then you get your final answer. The x squareds are gone. 3x and 2x is 5x, and 5 and 4 is 9. So it's actually 5x plus 9 when you do it. Okay. Now sometimes you don't have to necessarily work it out. I always just like working it out just to see if I can. Next question, just a straightforward side view. So the side view is going to be 5 wide. It's going to be 2 tall. Then you've got this line. So let's just draw that bit in first. So I'm 1, 2, 3, 4, 5 wide, 2 tall, and then it caves in there. And then I'm going to go 3 more up here. So now I need to go 3 up here, 3 up there, and then coming across, and I think that's 2 marks. Next one, so we've got our journey graph. We've got Simon stopped 3 p.m, so it's 3 p.m. How many minutes did he rest for? So he stopped from there to there. Now it's a good idea to get a ruler just so you can come down the line properly and see where you're at. And it looks like to me he stopped for half an hour. So 30 minutes is that one. How many minutes is 30? How far was Simon home at 5 p.m? So he would go up the 5 p.m. line, so we're here, and he's clearly 20 kilometres from home, 20 kilometres. Next one, at 5 p.m. he stopped for 30 minutes, so let's just draw that in. So 30 minutes is to there, and then from that point, then he cycles home at a steady speed. It took him an hour and a half to get home, so we're currently at 5:30, an hour and a half to get home means he gets home at 7 o'clock. Get your ruler out and put it up to there. Okay, and there you go, we've finished the graph off. Complete the travel graph. That's the travel graph drawn there. Next question. Emily buys 12 bottles of water. The pack costs £5.64. She sells all 12 bottles for 50p. So let's just do how much she sells for. So 12 times 50p equals 600p, which is £6 obviously. Okay, work out the percentage profit she made. Well, the profit is £6. Take away the £5.64 is 36p. So she made 36p profit. Okay, now the percentage profit is the 36 over the original amount. Now this is in pence, this is in pounds, so I'm going to change everything to pence. So it's 36 over 564. So that's the profit over the original amount times by 100. Get you the percentage profit. So here we go, 36, oops, 36, let's get a fraction on. 36 over 564 equals that one, and just times it by 100, and you've got, there it is, 6.38, one decimal place. So when it says one decimal place, what I'll do is I'll write out two decimal places, 38 dot dot dot, and then it's easy for me to see that's a rounding to 6.4% profit. Next one. It's a probability table. So first thing we do on a probability table is just see what we've got in there in real numbers. So I'm going to add these together just on the calculator. So 0.09 plus 0.16 plus 0.21 plus 0.30, and I've got 0.76, so 0.76, and that means you're short by 0.24, because remember you want to get the 1 for probabilities, so you just do that on the calculator. 1 take away that last answer is 0.24, so we've got 0.24 missing here. Now if we look at the table, we've got an x and a 3x in the middle, so that's x and 3x is just 4x, so 4x has got to come to this thing, it's got to be that one, and therefore x must equal 0.24 divided by 4, let's just do it on the calculator, so divide that by 4, and I've got 0.06. The temptation would just be right, 424 is 6, so it's 0.6, but it's not at 0.6. So work out the value of, oh there it is, 0.06. So the table, let's have a look. Mary plays the game twice, work out the probability of Mary scoring a total of 8. So you've got to think how you're going to get a total of 8. So the way you get a total of 8 is, so 0 plus 8 don't work, 1 plus 7 no, 2 plus 6. So you can get a 2 and a 6, or you can get a 6 and a 2. You can get a 3 and a 5, there's no 5, a 4 and a 4, or a 4 and a 4. So they're your options. They're the only ways you're going to get an 8 in this list. So we need to take the probability of a probability of 2, which is 3 lots of the x, which is that one times 3, which is 0.18. So 0.18. And in probability just means times, so I'm going to multiply by 0.30. Or means add. 0.30 times 0.18 plus, and 4 is 0.21 times 0.21. So there's my probability. So now it's just a case of getting the calculator and working out. So I've got 0.18 times 0.30 plus 0.30 times 0.18 plus 0.21, that's right, 0.21 times 0.21, and press equals, and you've got 0.1521 is the probability that you're going to get a total of 8. Just writing down what happens to happen to get it, then you just work on the probabilities. Next one we've got identical pair of boots are sold in London, Geneva and Paris, and these boots have these prices, the exchange rates of these. Now as soon as I say the exchange rates, what I want to do is I want to write down a quick flow chart. So I'll start with the 1, so I've got a pound going across to the Swiss francs, and that's times them by 1.39, and then I've also got the pounds into the euros, so euro sign is times 1.27. So if I see an exchange rate, I'll nearly always write these down, because that means I can go that way and I can come backwards as well. I'm not sure that's a very good focus, is it? I need to have a twiddle with this thing. I think that's a bit better. That's a bit better. Right, so there's the what's that? The flow chart's done. Right, which is the best value of London, Geneva or Paris? So I need to get them all right. So London I've got is, so we've got London is 115. Okay, Swiss francs. So Swiss francs, I want to get that to pounds, so I'm going to do the 189 Swiss francs. I'm coming back to the pound, so it's 189 divided by £1.30 or 1.39. So calculate a job. So where are we at? 189 divided by 1.39 is £135. £135 and 97p. So London's much better. And then euros. So where are we at? The euros now. We've got 174 and we want to get euros back to pounds, so we're going to divide by this. So divide by 1.27 equals, in pounds, this one is 174 divided by 1.27, and that is 137 pounds, 137.01, just rounding that properly, and that gives me, which one's the best value? Oh, London's the best value, isn't it? London. Are the boots best value? Yeah, so the answer is London, isn't it? Okay. Next one, pie chart question. We've got 100 degrees here. We haven't got no clues there. What's going on? We've got a total of 900. Now the way you work out the angles in a pie chart is you get 360 degrees, and you divide it by the total. So divide it by 900, and that's equal to. So on the calculator, so 360 divided by 900, 0.4. So it's 0.4 degrees, and that's per pound. Okay. So in year 7, you've got the incomplete pie chart, complete the table. Okay, so the incomplete pie chart. So we've got to do 100 degrees will be 100 lots of 4. So we've got 100 times 100 degrees. No. What I'm doing, divide by 0.4 tells me what I've multiplied by, doesn't it? So divide by 0.4 equals on the calculator 100 divided by 0.4 is 250. So I'm thinking the year 7's at £250. So if there's £250 there, times by 0.4, I should get 100 degrees. Let's just double check. 250 times 0.4 is 100 degrees. That's okay. And then this last one is, well, if the total is 900, these all should add 900. So if I just take all these 1, 2, 3, 4 from 900, I'll get this missing one more die. So let's go for that one. So we've got 900. Take away £162.50, take away 125, take away 225, take away 250 equals £137.50. 137.5, but it's money, so you go money's 2 decimal places. So that one is number 9. Just looks like a straightforward Pythagoras questions, isn't it? You've got 3 sides, you've got right angle triangle. See right angle triangle, you're immediately thinking of Pythagoras and trig. So Pythagoras is a squared plus b squared, a squared plus b squared equals c squared. C squared's always that one, opposite the right angle. So I've got x squared plus 4 squared equals 8.5 squared. X squared plus 16 equals something over there. 8.5 squared equals 72.25. So x squared must equal that one, take away the 16, which is 56.25, and then you can square root that, so x must equal square root of that thing is 7.5. 7.5, where I got the value of x, there it is there, 7.5. Next one. Ingredients question, 8 shortbread, what's the greatest number of shortbreads you can make? So the way I'm going to work this one out is I want to know how much ingredients you need for one biscuit, and then I can figure out how many biscuits you can make with these ingredients. So one biscuit is just divided by 8, biscuit, so I'm going to just divide by 8 here to get down to 1. So I've got 120 divided by 8, let's go, 120 divided by 8, nothing should be done in your head here, so even if you think you know it, just go for the calculator. 60 divided by 8 is 7.5 grams for caster sugar, and then 180 divided by 8 is 22.5 grams for the flour. So we've got grams and grams and grams, and that's butter, flour, and caster sugar. Right, so butter, we've got 330. So how many 15s can we get into 330? So we're doing 330 divided by 15, which is 330 divided by 15 is 22. So we can make 22 biscuits with the same amount of butter if we've got enough of the other ingredients. The caster sugar one is 60 divided by 7.5, which is 8. There we go, 60 divided by 7.5. Always double check on the calculator. Get 8 biscuits. Biscuits. I'm doing 64. It's 200. Ah, come on, Muppet. Right, so try again. 200 divided by 7.5. I thought that was a bit far away. Equals, so we can scratch that one because that was a mess up. I looked at that number, didn't I? So 200 this time divided by 7.5 is 26.66. 26.666, so we can make 26 biscuits there. No one wants 2/3 of a biscuit. That's a bit rough. And then the last one, is that right? 200 caster sugar, 7.5. Yep. Next one's 450 grams of flour in the cupboard. We're going to divide that by 225. 22.5 equals 450 divided by 22.5, and that's 20 biscuits. Biscuits can be made. So the issue now is the most number of biscuits I can possibly make is 20, because I don't have enough flour to make 26 biscuits with the caster sugar, and I don't have enough flour to make 22 biscuits. I only have 20. So the answer is here is 20. Next one, the Singh family and the Peterson family want to go on holiday. The Singh family buy 2 adult tickets, 3 adult tickets, and they pay that. They buy that. It looks like it's going to end up as a simultaneous equations question. So look, 2 adults and 3 children. So 2 lots of adults plus 3 lots of the children. It costs £28.20. Petersons pay for 3 adults plus 5 children, and they pay £44.75. Okay. Now my method for the simultaneous equations job is to get the first things the same and then do a takeaway, figure out the second one, sub back in. So here we go. So times this one by 3 to get that to be 6, times this one by 2 to get that one to be 6. Times the whole line now. So we've got, what's that, 6a plus 9c equals 28.2. 28.2 times by 3. And I've got 84 and 60. Times this lot by 2. You get 6a plus 10c equals 44.75 times 2 is 89.50. And now we're going to do a takeaway. So we always do a takeaway here. And be careful. So you got 9c take away 10c. You can do it the other way around, but you've got to be consistent. So let's just do it that way. 9c take 10c is minus 1c equals an 84.60. Let's go 84.60. Take away 89.50, is that right, is £4.90, yep, for 4.90, so minus 4.9, so the cost of the child's ticket must be £4.90 p. Okay, you would just divide by minus 1 and then that'll be sorted. So the children cost that bit. You take this number, you throw it back into here, and you can figure out what the adults are. So now we go 2a plus 3 lots of £4.90s must be £28.20. So 2 lots of the adults plus 3 lots of £4.90. 3 times 4.9 is 14.70 is £28.20. You can take that off. So 2 lots of the A's, 2 lots of adults is 28. There you go, £28.20. Take away that £14 thing is £13.50. And so the adults just divide by 2 equals £6.75. Okay, now to check you've got this right, and you might as well check so you can smash the 5 points on this one, is you can take these two answers and throw them into the second equation, just see if you get that number there. So that's going to be quite quick, so it's all calculated. So I've got 3 lots of the adults is £6.75 plus 5 lots. 5 lots of the children's of £4.90, and then I'll just get my calculator and hope that comes up to a right number. So I've got 3 times 6.75 plus 5 times £4.90, and I've got a total of 44.75, and that's actually correct because that's what I was looking for down here. So I know these are the answers. So there's my answer for that one, and there's the answer for the children. Okay, it's a 5-point question. Next one, recurrent decimals. So sure, bunch of ways doing this one. I started to do it the same way. No, it's okay, isn't it? So 0.43 with a dot just on the 3 is, so the number is 0.43333, shooting off forever. I'm going to multiply by 10 because only one thing repeats. So now I get 10n equals 4.333 shooting off forever. I'll write the n underneath again, 0.433 going off forever. I do a takeaway, and the whole point of the takeaway is to get rid of the recurrent bits. That goes. That changes to a 3, that changes to a 1, so I get 9.3, or 3.9 even the other way around, and 10n take away n is 9n. Now I multiply by 10 to get rid of the decimal point, so now I've got 90n equals 39, and then finally divide by the 90, so n equals 39 divided by 90. These will both divide by 3, and which gives me 13 over 30 as our answer. Now we can just, we don't need to check it because it's there, isn't it? But if you type it in your calculator, it'll come out with that, be that recurrent decimal. Y take away 2, y take away 5. I use a thing I call a smiley face for this thing, so that one times that one is y squared. This one times that one is plus 10. Underneath you get minus 2y, underneath that one you get minus 5y, and the bottom two are going to give me minus 7y when I put them together. It gives me an answer of y squared minus 7y plus 10 as our final answer for that question. Prove algebraically this is an even number, so it looks like there's a tricky way to do this one and a bit bog standard way of doing it. I'm going to go the bog standard way, which is just as expanding out this bracket. I could factorise out, so I can say I can factorise, and all you people who are saying factorise it, no, I'm not going to do that, I'm just going to expand it. So I've got, what I've got 2n plus 1, 2n plus 1, take away 2n plus 1, okay, which makes it even easier to factorise now, but I'm going to expand this bracket out, so that's going to give me 4n squared plus 2n plus 2n plus the other 2n is plus 4n plus that 1, take away 2n plus 1, so it's equal to that one. And then if I've got 4n squared, the 4n take away this 2n is plus 2n, and the plus 1 take away that plus 1, remember this minus hits the plus, becomes minus, so that's going to go away, in fact, isn't it? So plus 1 take away 1 is nothing. And then because I want to show it's an even number is 2 times anything, so I want to factorise out to 2 now, so I've got a 2 into, and then it's 2n squared plus an n. Now I'm not bothered about like a whole factorisation, I'm not bothered about pulling out an n, because I only want to show it's a multiple of 2, so it's a multiple of 2, and therefore it's even. Okay, 3 dots just means a shorthand for maths for meaning therefore. Mathematicians are notoriously lazy, we don't write therefore because it's too long a word. Shelley wants to find out an estimate for the number of bees in her hive, so we don't know how many bees in her hive, so we're just going to call that X bees in the hive. On Monday she catches 90 bees and she puts a mark on each of them, so we've got 90 over X. So X is how many bees we've got all together, but we don't know this number, we're trying to figure it out, but we know 90 out of that many are going to be marked up bees. Now on Tuesday she catches 120 bees and 20 of these have been marked, so we've got 20 out of the 120 being marked. Now we want this top number to be 90, so we've got to try to do some sort of cunning equivalent fractions to get this to be 90. Now I'm going to take it down to 10 to kick off with, then go up to 90. So if I divide it by 2, I get 10 out of, divided by 2 is 60. And then I can multiply by 9 is 90 out of 9 times 60 is 54 with a 0. 9 6 is 54. And that tells me that my estimate is 540 bees. Okay. Shelley assumes that none of the marks have been rubbed off on Monday. Tuesday, if the assumption is wrong, explain what effect this could have on the answer. So if they're marked off, let's just imagine there's a number there. Let's say if there was 40 bees, so 20 have lost the markings. So you got 40 out of 120, which gives me 20 out of 60, and then I times by 9, didn't I? So it'd be 180, so it'd be twice as many. Would be what? Shirley assumes that none of the marks have been rubbed off on Tuesday. So let's just have a guess. So assume that some have been marked. Assume this should have been 40. Assume they should have been 40 out of 120 which are marked. So we're trying to get this to be 90, remember, so we divide it by 4, so that would be equal to 10 over 30, and then we times that by 9, so that would equal 90 out of 270. 9 3s are 27, so you can see there's there'll be less bees in total. So if Shirley's assumption is wrong, the answer would have been smaller. The answer would be smaller. Okay. Right, Kira used a calculator to work out the value of an x. She wrote down the first 2 digits on her calculator. She wrote down 7.3. So it could have just been 7.3, it could have been 7.31, it could have been 7.32, 7.33, 7.34, 7.35, 7.36, 7.37, and so on. So the interval goes from 7.3 is the smallest you can have, which is less than the number that she's actually got. And this is going to be less than 7.4, okay? You could go less than or equal to 7.3 39999 or 7.39 with a dot on the top, but you can't have 7.39, okay, because you can get a bigger number than 7.39, which chops off to be 7.3. This is called truncation, so she's truncating the number. Next one, B is a sector, okay, it's got a radius of 7. The area of the sector is 40, so in here we've got 40. Calculate the perimeter of the sector, so I want to go all the way around. So the way they've worked out the area, so let's say we've got some angle here we'll call x, because I don't know what it is, so I'm going to call it x. The way you work with area of a circle is pi r squared, so we've got pi times 7 squared, that would be the full circle, but we've only got out of 360, we've got the x out of 360, so we've got x out of 360 times by pi r squared, and that equals 40 apparently, okay. This is equal, I'm going to multiply this side by 360, so x times by, and this is 7 7s are 49 pi equals 40 times 360, let's go, oops, get off, 40 times 360 is 144,14400. Now I'm just going to divide by this 49 pi, so x is equal to, and the way I'll set this up is I'll go, I'll do a fraction, put that last answer. I used ANS button quite a lot because it's more accurate and I'm not going to mess anything up. So push 49 pi on the bottom there, 49 pi on the bottom. Press equals, and I've got x is this angle of 93.544, and that's going off forever degrees. And you notice I'll write this bit because I want to be accurate. I'm not going to round until I get to the end of the question. So that's our x angle. Calculate the perimeter. So the perimeter is this length of the arc, which is part of the circumference, plus a 7 plus another 7, isn't it? Okay, so the circumference of a circle is pi times diameter. Pi times, in the diameter of this thing, if that's a radius of 7, the diameter must be 14 to go all the way across. So pi times 14 is the diameter of the circle. The circumference of the circle. And then I want to have x out of 360, so only that fraction. So x out of 360 times by this thing. Would get me the arc AB, but then I've got to add this 7 and add that 7, so I'm going to add 7 equals, and then I'm going to go for the calculator. Remember, the x is just the last thing we had in our calculator. So I've got I've got ANS over 360, and then times by pi times 14, so shift pi, and now I'll put the 14 in brackets, that's what it looks like on the paper, plus the 7 plus the other 7 equals, and I've got this number. It's equal to 25 point, and I'm going to 3 significant figures, so I always write 4, 2, dot, 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 1, 2, 3, 4 figures, and then to round that is 25.4. I think you've lost that on the camera. It says me round it to 25.4. Next one, number 17. What are we doing? We're going to reflect the shape on the line x equals minus 1. Well, the line x equals minus 1 is a straight up and down line through the x-axis at minus 1. So this is our line of reflection here. Let's just reflect that one. So it bounces 2 squares across, so 2 squares this side, this is 3 that way, and then there. So there's my first bounce over, so that's Q. And then reflect on the line y equals 0. Y equals 0 is actually another name for the x-axis. It's a bit weird why that's called that, but I'm sure your maths teacher might have explained why this is also called y equals 0. Any y coordinate on this line is 0, is basically it. So bounce it down, it's going to go from here, here, and then to here and here. So there's the reflection down, and this is R. Describe the single transformation. Well, now to get back over here, we're just going to rotate 180 degrees. And the centre of rotation is where the two mirror lines cross over. So your centre of rotation's here. You could just guess that one, but minus 1 on the x-axis and 0 on the y-axis. So minus 1, 0. There we go. Next one. It takes 120 minutes to fill a swimming pool using 5 taps. So this type of question comes up loads. So if you see that thing, the first thing to figure out is how long it takes 1 tap. So 1 tap is obviously going to be 5 times longer than that one. Is equal to 5 times 120, which is 600 minutes. So you've got 600 minutes for 1 tap. How many minutes will it take to do 3? So if now we know that one, 3 taps is going to be 600 divided by 3, 200 minutes. State one assumption. So the assumption I'm making is all the taps run at the same rate. So taps running at the same rate. Okay, however you want to phrase that. You can phrase it however you want, really. Next one, we've got simplify this thing, so expanding the bracket out, so the power hits everything on the inside, so let's just write that out. So 3 to the power of 4, then you've got x to the 5 to the power of 4, y to the 6 to the power of 4. 3 to the power of 4 is 81, I know that one, but let's just do it on the calculator anyway. So 3 to the power of 4 is 81, so 81 there. X, and the rule for brackets is just multiply the two things, that's 20. And then y, and then multiply them is 24, 6 fours is 24, so that's all that one is. Simplify a triple bracket, so what I do with triple brackets is I expand this one first, I'll leave that one alone, so I've got x plus 2, and then let's just do this one on top, so we've got x squared, we've got a minus 12, minus 3x, and then plus 4x. These two things are just going to give me an x on there, so plus 1x, that's right. So this is going to be x squared plus an x minus 12 in that one, so that's expanding the first bracket, and this is equal to, so all you do now is multiply everything in here by x, and then multiply everything in there by the 2 underneath. So multiplying by x, I get x cubed, plus x times x is x squared, minus x times 12 is 12x, so that's everything multiplied by the x. Now I'm going to multiply everything by 2, so 2 times x squared is just 2x squared, and I'm going to write that underneath the x squared. So I get plus 2x squared, 2 times the x is plus 2x, and 2 times minus 12 is minus 24. And the idea now is you can just add them two together, so you've got x cubed, you've got 3x there, x squared even, minus 12 plus 2 is minus 10x, minus 24, jobs are good one for expanding triple brackets. What's going on here? So we've got congruent triangles, so these are just two the same. We've got the area of rectangle ABCD, ABDE. So the rectangle is the area of these two put together. AB, so AB is x, and then AE would be 3x there. What am I trying to work out? Work out the length of this line here. So what do I know? So I know the area of this thing is going to be 3 lots of x squared. I don't know where I'm going here. Do I know any other clues? Not yet. So rectangles are there. So I need to work out the area of this thing, don't I? So let's have a look. Let's just draw that out. So we've got that line. I like to draw them out so I can see it separately and I don't have to get confused about what's going on. 3x and 24. Right, so we're talking about area. So the area of a triangle. So area is half AB sine C. So if this is C, this is a little c, that can be A and that can be B. A and B, we don't really care where they go. So the area, so we've got half of 24, which is 12, times by 3x, sine of 30. Okay, let's try and work that out. So we've got half of 24 is 12 times 3x, and the sine of 30, so times by, what's the sine of 30? It's half, isn't it? But there we go. Sine of 30 is half, times by half, that's our area. Okay, and this thing is 36, half the 18x, so 18x, okay, and that's got to equal the area of this thing here, doesn't it? Oh, no, so 18x is the area of one triangle, okay, so that's the area of one triangle, so that's equal to that one, so equal to that one, so I've got 18x here, and I've got 18x there. It says the area of the rectangle is the area of the triangle ABEFE plus the area of the triangle, so the two of them. So we've got 18x plus 18x is 36x must equal the 3x squared that we had earlier from the area of the rectangle, just those two times together. Now, we know x can't be equal to 0, that's quite an important point, because we're going to divide by x in a second, but we don't want it equal to 0. There is another way to do this one, but let's just discount that one. So we know x is not equal to 0, which means I can divide. Let's divide by 3 to kick off with, so we get 12x equals x squared. Now let's divide by x, so 12 equals x, and then we finished. So the x equals 12, so that's 12, and this one must be 3 12s, so 3x must equal 3 times 12, which is 36. Okay. Well, to finish up better off, 3 times 12 is 36. Now, I'm only allowed to divide there by 0, divide by x, because I know x isn't 0. It's a technical thing. A technical thing, you said. Well, next one. Right, so what we're doing here, the cross section of the shader, the curve is that, and both are measured in centimetres. Find the depth of the ball. So I want to find how far down this is here. So I need to find this number here. Now the nice thing about a quadratic, which this is x squared, is that it's symmetrical. Okay, so if I find this point, I know this is a 0, then this bit is right in the middle of these 2 points. So that's what I'm really looking for. Now these 2 points are occurring when y equals 0. So I've got x squared over 10 minus 3x equals 0. This is what I'm trying to figure out, and that'll tell me these 2 points. What can we do here? Let's just times everything by 10 to get that 10 off the bottom, because I don't like that. X squared minus 30x equals 10 times 0 is 0. And that's multiplying everything by 10, just to get that off the bottom. I'm going to factorise this out, so it goes x into x minus 30 equals 0. And what this tells me is x equals 0 or 30. Okay, so that's what that's telling me there. So if I go up here, this is the 0, this is the 30. So clearly the middle point is 15, so we've got 15 in the middle. That's not what we're looking for, we're looking for the y value. So when x equals 15, I need to run that through the equation. So when x equals 15, y is equal to 15 squared over 10, take away 3 lots of 15, okay, and then you can just get your calculator and set that up. So we've got in brackets the 15 squared over 10, take away 3 lots of the 15, and just run that through there, is minus 22.5, minus 22.5. So this point down up here on our graph is minus 22.5. The depth of the ball is obviously 22.5 centimetres, so it's 22.5 centimetres. That's how deep it goes down. Okay, so notice I'm not putting the negative bit in because it does ask me for the depth of the thing. So I've dropped the negative bit there. That's just on the graph, it goes down to there, but the depth of the ball's a bit weird if you're saying the depth of the ball is negative. Next one drawn on the graph. So this is just a circle. X squared plus y squared equals 4. Now the thing for circles, it's x squared plus y squared equals the radius squared. So the radius of our circle here, radius equals 2, because 2 squared is 4, or the square root of that is 4. And it doesn't look like I've got a compass. Oh, that's a bit irritating. Why don't I have a compass? So what I would basically do there is I would start here, and I would use a compass in the exams. I would just whack a circle around there, it would go through that point, it would go through here, and it would go through there. Some sort of mess like that one, that's a bit rubbish. Please use a compass when you're doing that one. Sketch the graph of the cos graph. So the cos graph looks like this thing. So it's like, starts at the top, runs down, runs up again for 360, and it just keeps going actually forever. But your key points are 90s, -1 at the top, -1 at the bottom, and these are 90, 180, 270, 360. So all the key points, crossing point, maximum, minimum points, are just jumping in 90s. So if I look at the 90 marker, so 90 is going to be a point, so it starts at 1, goes down to 90, goes down to 180, 270 is a key point, 360 we're back to 1 again, so that looks like it's there. So there's my points. And then you don't draw a V, because it looks like a V at the moment, because it's actually a curve. So it curves round, and then comes down, curves upwards, curving upwards, and then through that point, and then curving round again, like you're going to come back down again. So you've got to make sure it's a curve, not just a straight V. And then it just goes off forever, the cos graph. So I've only got to go off to 360. Last one. Okay, we've got ABCD is a regular heptagon. Heptagon's a bit of a pain because that's 7, isn't it? 1, 2, 3, 4, 5, 6, 7 sides, so 7 sides. The area of the triangle ABG, so the area of this thing is 30, so we've got the that triangle there. Yeah, that thing is 30. Calculate the length of GB, so I want to know how long this is. That's what I want to find out in the end of the game. Now, think about this thing. What do I know? The regular heptagon. The area of the triangle is this thing. Well, I don't know anything about the triangle apart from the area, do I? Oh, I do, because I know interior angles. So the 3 sides. So then I remember 3 sides, angles and triangles, and some people remember the formula n minus 2 times 180. I just remember it's 180 for a triangle. 4 sides, we just add 180 on, you get 360 for a 4-sided shape, which is right. 5 sides, add another 180 on, so all I'm doing is adding 180 every time I add a side on, I add 180, so that's 540. 6 sides is going to be, add 180 on, is 720, and then 7 sides is going to be 900 degrees. I'm just adding another 180, aren't I? So what we know is now that the angles inside this heptagon, the inside angles add up to add up to 900, which makes this angle at the top here, or just one of them, so 900 divided by 7, and on the calculator this is going to be quite an ugly angle now, so 900 divided by 7 is 900 over 7, because it's an ugly angle of 128.57 goes off forever. So that's our angle up here, so we've got 128.57 whatever in there. So a bit more information. We said the area, so now we've got half AB sine C, so half AB sine C equals 30, but we don't know AB are, we know C, that's going to be C, we don't know these sides, but we do know they're the same. So I'm going to call these two things, what am I going to call them? I'm going to call them X, because X is always a good starting point. So we get half of X times X, sine of this horrible angle of 128.57 whatever, must come to 30. Okay, so X squared, I'm going to times this side by 2 to get 60. X squared in this thing, so what's that? So sine of that angle, last answer, so I'm just using the ANS button there, if you can see that, ANS to keep things accurate, is times 0.78, and then what runs off forever. So now I'm going to divide this by that thing, so X squared must equal, so 60 divided by that, so 60 divided by that last answer is this 76 and a bit, 76.74 whatever, so X equals a square root of that of ANS equals, and I've got 8.76 running off forever. Okay, so now let's have a look at what we've got now. So now I've got to go back to this triangle again. I've got 128.57 going off, I've got 8.76 going off, and 8.76 going off forever, and I'm trying to find this side. This is the whole target, wasn't it? Get this thing here over here, so I'm going to call this our side A, because now I'm going for the cosine rule. Cosine rule is A squared equals B squared plus C squared minus 2BC cos A. Okay, so that's equal to, these are the B and C, this is the A, so B is 8.76 going off forever squared plus 8.76 squared minus 2 lots of 8.76, 8.76 cos of the 128.57. Ugh, that's just a big horrible calculation, isn't it? So let's go for that one now. So we've got answer squared plus answer squared, so that's 8.76. Take away 2 times the answer again, 2BC, and then we've got cos of the last one. What was the sine angle thing? Where's it at? So it was 900 divided by 7, that's just to that degree. 900 divided by 7, so that was the 120.57. So let's see what that's coming up with. So that's 249 point some mess, 249.18 running off forever. So A must equal, and we're going to 3 significant figures, just having a quick check back at the question. So we want the square root of that answer, and I've got 15.2 significant, how many? 3 significant figures, so I write down 4, 15.78, going off forever, so round that off, you got 15.8, okay, and that is the Pixi predicted paper for the paper 2 2023 exams. Okay.